Today, we're going to take this model rocket design from concept to aerodynamic insight. We are using OpenVSP for geometry creation and Stallion 3D for CFD simulation and analysis. We start in OpenVSP, NASA's open-source parametric geometry tool. Here, we modeled a multi-fin rocket with a smooth nose cone, cylindrical body, and 4 canted fins for stability. OpenVSP makes it easy to adjust nose length, body diameter, fin sweep, and thickness with simple sliders. Once the design is ready, we export it as an ASCII STL file, the format Stallion 3D reads for aerodynamic analysis. In Stallion 3D, we go to Design Import/Edit STL file, load our rocket geometry, and align it with the flow direction. We set the correct units, confirm the scale factor, and check that all surfaces are properly oriented. Next, we define the flight conditions under flow field flow parameter. For this run, we are using angle of attack, 0 degrees. Speed, Mach 2. Air at sea level conditions. We also enter the reference area, moment reference length, and the rocket's weight and center of gravity coordinates. Under CFD Solver and the Setup CFD Solver menu, we choose a grid size, here about 512,000 cells, and use the Reynolds average Navier-Stokes solver and the K-epsilon turbulence model. We also choose second-order solver for accuracy. The domain size is set to comfortably surround the rocket, and radiation boundary conditions handle the far-field effects. Be sure to set the boundary length to about 8 times as long as the rocket length. Then, we run generate grid/solve flow. The solver first builds the grid around our rocket, then marches through thousands of iterations, refining the pressure and velocity fields until convergence. Here is our result, a pressure distribution map along the rocket's body and fins. High-pressure zones are visible on the nose and leading edges of the fins, while low-pressure regions form in the wake. From here, Stallion 3D can compute lift, drag, side force, and stability derivatives, essential for predicting flight performance. By combining OpenVSP for fast, flexible geometry creation with Stallion 3D powerful CFD solver, you can go from concept to detailed aerodynamic insight in a matter of hours, without expensive meshing software or external solvers. Whether you're building rockets, drones, or aircraft, this workflow gives you the aerodynamic clarity you need before the first launch. For more tutorials, visit HanleyInnovations.com. Thanks for watching.